Hi grade 10s. Okay, so we're walking through your people's exercise in your textbook. I'm going to do question by question, and I want you to have your pen and paper with your pen and your book with you so that you can copy down these examples into your book. Okay, the first one, I want you to first listen to it and take down notes as I'm talking, and then as I go through the next, I want you to try them on your own first and then see if you got them good at. Okay, so what we learned so far about the parallelogram, I gave you all the properties of a parallelogram. I told you that in Euclidean Geometry in grade 10, we have something called theorems, right? And the theorems are basically the proofs of how they came about to understand that these properties exist. And there's certain theorems that you need to study off by heart. Those are the ones that we practiced in class as well. We even wrote some mini tests about them. Okay, they're in your textbook. I will take a screenshot of the PDF textbook and put it on the group so that you understand or you know exactly what I'm talking about. Right, those you have to study word for word off by heart. Okay, you have to know how to do them. They're easy marks, especially for the students that are very good at studying things off by heart. They're easy marks for you. Okay, the only thing that could change is, for example, if we give you the diagram in the textbook as ABCD, maybe in the test we can use PQRS. It's the exact same thing. The only thing that changed is the naming of the alphabet, right? Now there's different theorems. Like I said, I'm going to take a screenshot and I'll put it in the group so that you know exactly what I'm talking about, or I'll tell you the page number in your textbook. All right. From those theorems and from the properties that we learned based on those theorems, we can use them in reverse, okay, to prove that a certain quadrilateral is a parallelogram, and that's very important. That's what we're busy with at the moment, right? So I've just jotted down the 5 things that you should remember or you should be looking for. Now, if you compare this to knowledge that you already have or things that we've done that were similar, remember in grade 9 we did similarity and congruency. And in congruency, there were 4 different ways that you could prove that 2 triangles were exactly the same, right? There was the RHS, SSS, SAA, and SAS, right? And you needed to remember those, and not just remember those and understand them, you needed to know when to use them in which context. It's the same thing that's happening over here. There's using each of these properties, you need to know, given the question, which one of these you want to use. Okay, so it's very important that you understand this and you also understand when to use them. Let's go through the first one. We know that a parallelogram has opposite sides that are parallel and equal. So if you see here, this first one is one pair of opposite sides that are parallel and equal. If you can prove in any quadrilateral that the opposite sides are one pair of it, okay, one pair of opposite sides are parallel and equal, you can conclude that that quad is actually a parallelogram. If you can't do it for one being both parallel and equal, but you can do it for both sides being parallel or both opposite pairs being equal, then it's also a parallelogram, okay? Or you can opt to find that the diagonals of the quad bisect. Now, what does that mean? I know quite a few of you are visual learners. Let's show you what I mean. Let's say here's my quad. Okay, we don't know what type of quad this is. Let's say I give you information that this side and this side are equal, this side and this side are equal. You can conclude that this shape over here is not just any general quad, it's in fact a parallelogram. How do you know that it's a parallelogram? Because can you see that the diagonals, remember the diagonals go from opposite vertices, right? They are equal to each other. This part's equal to this part, this part's equal to this part. So you can use this rule or this property over here that the diagonals bisect. Therefore, this here is a parallelogram. Another one that you could use, opposite angles are equal. So let's say we have the shape over here. We don't know what it is. We know it's a quad. I give you information that this is equal to this one, or you use some proofs, you calculate, however it is, you prove and you get that this equals this one equals this one. You can now conclude that this shape over here is in fact a parallelogram because opposite angles are equal. Okay, let's quickly just do for 1, 4, and 5. Let's say here's our quad, right? Let's say you have information, or you work out information that these two sides are equal and they parallel. You can conclude that this here is a parallelogram. Or let's say you have that this and this are equal, this and this are equal. You can conclude that this is a parallelogram. Or lastly, let's do, okay, let's say you have information that this side and this side are parallel, or this side and this side are parallel. You can conclude that this is a parallelogram because opposite sides are parallel. So this is very important that you know these 5 properties over here on how to prove that something is a parallelogram. Now let's take this knowledge that we have and actually answer a question. Here's a question. It says that we have parallelograms. Okay, so we're telling you that it's a parallelogram. Therefore, for the one that I highlighted in orange, A, B, C, D, here it is. Okay, we know that all the properties that I just mentioned now and everything that you have in your book are all true. Okay, we know that in and A, B, D, E, so that means the blue one, we know that it's a parallelogram. So all the properties about the parallelogram hold true are given with DF equals to DB. I highlighted that as well. DF equals to DB. They want us to prove that BCFE is a parallelogram. Okay, let me highlight that. BCFE. BCFE. So this big one over here, we need to prove that it's a parallelogram. So that means in the yellow shape, we want to prove one of these 5 things over here. So now we need to decide which one we're going to use. And remember, in maths, we don't generally give you information just for fun, okay? So it's obviously got to do something with this part here and something with that there, okay? Now, if it's given us that DF equals DB, if you look in EBCF for this BCFE, can you see that that information given to us, the green part, is actually got to do with the diagonals? So we already got that one diagonal is bisected. We just need to prove that the other diagonal is also bisected. And if we can prove that, we're done. We can just say that this is a parallelogram. Now, how do we prove that this side here is actually equal to the side here? That's coming into place with these 2 parts of the parallelogram. Okay, so can you see that DC is actually equal to AB? How do I know that? Because they're opposite sides of the orange parallelogram. Okay, and then can you see that AB is actually equal to ED? They're opposite sides of the blue parallelogram, and we know opposite sides of a parallelogram are equal. Since AB is both in the orange parallelogram and in the blue parallelogram, right? It's the exact same length as ED and DC. Therefore, ED is equal to DC. And that's exactly what we wanted. We wanted to prove that the other diagonal is bisected. Now that we have the other diagonal bisected, this yellow parallelogram is yellow shape is actually a parallelogram. How do we write this down? So that was us thinking and going through our game plan. How do we write this down? I'm going to say in A, B, C, D, AB equals DC. That's what we said. Remember, everything in Euclidean geometry, for every statement you put down, there has to be a reason. So you can abbreviate parallelogram as PALM. Okay. I mentioned in class that I don't just want you to write down property of parallelogram. I want you to tell me which property of the parallelogram you're using. In this case, we're using the property that opposite sides are equal. Please be specific. Okay. right? AB equals ED. And to the question that might arise, do you have to write down the reason twice? Yes, you do, because it's two separate statements, so two separate reasons, okay? Now the thing, do you notice how using color makes it so much easier to understand because we see which shapes we're actually working in. So please use color pens or highlighters or crayons, anything, just to make it easier for yourself. And I know there's some students who don't like carrying color pens, and then guys, it actually makes it so much easier to understand the question. Right, so we already discussed AB is equal to AB, so we can say therefore DC is equal to ED. Now this here is a conclusion. We don't need to write down a reason for it. Okay. And we can say, therefore, I'm going to name it exactly what they wanted. BC. If you named it anything differently, so if you went EFCB, that's perfectly fine. If you did it in any other order, that's fine. As long as when you're naming it, it has to go in a anti-clockwise, or in a clockwise order or an anti-clockwise order. So you have to go EFCB, okay, or FCBE. Right? You cannot go ECFB. That's not going in the correct order. So please be careful with that, okay? Right, so we put in down our statement. Now we need to give a reason. Why do we think that this yellow one is a parallelogram? And the reason for this is okay. So diagonals of the quad bisect. I'm just going to, because I forgot to mention what was given to us over here. I think I should have mentioned it over here. DF equals DB. Please mention that. How do we know this information? It's given to us. Sorry, I forgot about that. I know we spoke about it, we just forgot to. I forgot to write it down. And there we go. That's how you would answer a question like this. This is very important that you know how to answer these questions. What I'm going to do is I'm going to try and do like two and put them in separate videos to make it easier and slightly less threatening than watching a 30-minute video or a 50-minute video. Okay, please keep practicing.